and welcome back to continue chapter Inheritance in the course INFO404 Advanced Object-Oriented Programming. Reminder, this course relies on the textbook Core Java for Horstmann. And we are in chapter 5 in this textbook, and we will continue the sections from generic array lists and until the end of the chapter. Last time we saw the classes, superclasses, and subclasses section. We talked really serious things about objects, the cosmic superclass, in which we defined the equals, the toString, the hash code, the relation between the equals and the hash code, and we demonstrated all of this using demos and using the listings of the book. So we will continue today with an appetizer on the generic array lists because there will be a dedicated chapter called collection in which we will see the array list generic class and all the framework of the collection. So after the generic array list today we will see the object wrappers and autoboxing. We will see also methods with variable numbers of parameters, enumeration classes, reflection, and we will end the chapter with design hints for inheritance. So as usually, this video will be posted on YouTube and you will have to just click on the description box in the YouTube description of this video in order to see the outline and to jump from one subsection to the other quickly without wasting your time. So generic array lists, just like in C when you use dynamic allocation, if you remember, in Java you can set the array size at runtime if you want to defer what is the actual size of the array. But once set, even though you can do it at runtime, once set, you cannot change anymore the array size. So a solution is the ArrayList class, which is similar to an array, but it automatically adjusts its capacity. So if you have a data that will grow, you can simply put it inside an array list. So some history now, and let's say that since Java 5, ArrayList class has become a generic class. In order to declare an array list, you must precise which type parameter it has. So for example, here we are declaring an array list of employees called staff. So we write array list of employee equal staff, and if we want to make this object variable refer to an object of this type, we create the object using the new and constructor operator. So new array list of employee again and empty parentheses for the default constructor. Before that, so let's do some history now. Before Java 5, ArrayList was not even generic, so there were no this type parameter. So there was a single ArrayList class, a one-size-fits-all collection. You can put inside whatever objects you want, and the objects that it can hold are of type object, of course. Before the array list even existed, there were a class called vector, which still exists until now, but vector is also a dynamic, manages also a dynamic array, but it also manages synchronization for concurrency. So if you don't have concurrency, you should use array list, and since we are in Java after Java 15, you should use, of course, a typed parameter array list. So as of Java 10, you can use the var keyword to avoid duplicating the class name. Instead of writing array list of employee equal new array list of employee, you just write var staff equal new array list of employee. You put just once the type parameter and the constructor call. Or you can omit the type parameter on the right-hand side if you declare the variable staff as array list of employees. So you can either write this syntax or this one. So you can write a staff is an array list of employee, which is equal to new array list of diamond operator without the employee, because this is a repetition, so the compiler can directly guess. So you use the syntax you want, but of course you have to use the type parameter and you have to use the array list unless you have a specific case in which you need concurrency to manage concurrency, so you use the vector type, which is also typed now. So let's see the array lists. In order to add elements to an array list of employees, you just invoke the .add method and you give an object reference or directly the object itself to the add method. And for example, here we added 2 employees to the staff array list, which are Harry Hacker and Tony Tester. The array list manages an internal array of object references, and as we have said already, it expands itself whenever the size reaches its end. So in order to ensure the capacity, if you already know you have 100 employee you want to add, you can just simply ensure the capacity to 100 before you begin to add those 100 employees. But this way, the first 100 calls to add do not involve any costly reallocation because you have 100 guaranteed free places. You can also, when you create the array, give to the constructor, use the other constructor which takes the capacity needed at the construction time. Notice here that 100 is not the size of the array. It is only the capacity. So maybe the 100 are not yet occupied, but they are available to be occupied. So in order to know how many elements there is in the array list, you invoke the method size, and in order to trim the array to adjust its size to hold only the elements they are there, you trim to size method. So let us look on the Java array list documentation, and we can see here our class Java, which is inside the package util, which has the following methods. We will see the other properties as I already told you in the collection chapter, but we can see here the add, the Boolean add we talked about that does not take an index and which appends a specified element to the end of the list. We can see another add with an index which here inserts the specified element at the specified position in the list. We have a get method in order to return the element, and we have a set method. What does the set method do? It replaces the element at the specified position in the list. So we have a set index element and we have an add index element. The add inserts, but the set replaces. So let's see if this is written in our slides. We continue our slide presentation, and we see that ArrayList class is not a part of Java. It is a part of Java utility class. So the syntax, bracket syntax, bracket open square and closing square is not available. So as we have seen in the documentation, in order to see the elements and change them, you have to use the get and set methods. So staff.set at index I, the object Harry, object reference Harry. So this means in the array syntax A of I equal Harry. The following code is wrong. Why? If you declare a list, new array list of employee of 100, and then list.set at the index 0, you put x, which is a certain variable of type employee. This is wrong because until now the capacity is 100 but the size is 0. You didn't add any element and you are trying to set. So this is very wrong. There is no element yet at the index 0. So a rule of thumb, you have to use the add to fill and the set only to replace. It's not like the A of I in the array syntax in which you use it for both things. To get an element at index I, as we have seen in the Java doc, you use the get method, and you get the element at index I in a variable of type employee because this is an array list of employees. Before Java 5, since it was not typed generic class, you get it inside an object unless you explicitly cast, which was very dangerous, and we will see why this was dangerous in the chapter generics. So, if you like the array syntax, but you want to get the capabilities of the array list, you can get the best of the both worlds. When you fill your array, you fill it inside an array list, and then you convert it into a simple array in order to access the elements quickly. So you do the following. You declare an array list of type whatever, X, let's say capital X, and you do the filling using the add method of the array list. The array list will expand its size gradually as needed. Once you know that your array list will not change in size anymore, you declare a variable of type array, this time new X of the same size of your list, array of X, square brackets list dot size, and then look what did we do. We will look at this on the documentation. We said list dot to array, and we passed our declared array as a parameter. So we gave our declared array to the list dot to array method in order to copy her elements inside this array. So let's see if this will work. We will consult the documentation and we will see if it has a toArray method. So this is the toArray method. It returns an array containing all the elements in this list in a proper sequence from first to last element. So this is a list. There is an order to this list. The runtime type of the returned array is that of the specified array. So you give her the array of type T, so it will copy the elements inside this array A, just as we are showing you. To add an element in the middle of the array list, you can do the following trick. N equals staff.size, where staff is the array list, over 2, and then staff.add element at the index n. To remove, you just give the index you want to remove, and the element will be removed from the list staff. But if you have frequent inserts and removes, the array list is not really the good data type. We just learned in the previous courses in I-2204 and I-2206 data structures and imperative programming that frequent inserts and removes require linked lists and does not work well inside array list because of the frequent shifting to the left and to the right of the elements whenever you have to insert and remove the other elements in the middle. So here, even if it is not you that is doing this, even if it's just an instruction staff.remove n, you have to know that internally, whenever you are removing the index n, all the elements that follow this index will be shifted to the left one place in order to fill the gap. So you as a programmer, you know that this is not good. This will take time and this will take effort for the program, and this is not good to do it frequently. If I have to do it frequently, I have to use linked lists. Okay, next you can, as you know, use the for each loop, which syntax is for and employee type, the variable e, 2 points inside which array list you have to do the loop and do something. So this is a for each loop that you can easily apply on the array list, just like you applied it on the arrays, on the primitive arrays, and we will see the iteration in the chapter collection, of course. Finally, let's go back to the array list documentation, and we can see all the methods. We will see the majority of those methods in the chapter collection, but until now we saw add, indexed add without index, add all. You can guess that it takes a collection of elements and it inserts them in the array list. We will talk about add all in detail in the chapter collection. We saw clear, which we can see clear now, which removes all the elements from this list. We have the clone of object. We will talk about this method inside the chapter. Interfaces we also contain, we will see them all. We will have to see them all and study them all. But now just look with me how it is easy to consult the Java doc. Let us see the listings inside the package array list, in which we demonstrate all what we have seen until now. So this is our listing. This is our employee class, in which we have the hire day, the name, and the salary of an employee as private instance fields. We have a constructor which takes the name, the salary, and the hire date in 3 integers. We have the getSalary method, the getName method, the getHireDay method, and we have the raisSalary method, and we all know about them. We saw them in the chapter, this chapter, Inheritance, in part 1, when we defined the subclass manager. But for now, we are studying only array lists. So, as you can remember, last time we created an array of staff, of employees. Now we are applying this program, but we are using array lists instead of simple arrays. So to do so, we have to import the utility class. We can only import the java.util.ArrayList since we are using only array lists. And then we add the employees, Cracker, Harry Hacker, and Tony Tester, and then we apply on them the for loop, the for each loop, and we raise their salaries, all of them, and then we print information about them. And this is a small listing about array list, in which you can open, try, and change something in order to understand. Now we will talk, before finishing this abstraction, we will talk a little bit about the compatibility between typed and raw array lists. We will talk just a little bit. We will be back on the generic chapter. Whenever you have a legacy code, a legacy class, suppose that you have the following legacy class. Suppose you have the class called EmployeeDB. Someone wrote this class, and inside this class there is, among others, these two functions, these two methods. The first method takes ArrayList list. As you can notice, this class is very old. It dates before Java 5, so before 2005. And the programmer that wrote it didn't even know about generics. So he wrote raw array list type. He used raw array list type. And again, he wrote another method called find, in which he returns a raw array list type. So here we have a method that takes an array list type, a raw one, without type parameter, and another method that returns a raw array list type, which is not typed. And our problem here is to know, is it dangerous to deal with legacy code? Okay, because sometimes you have to, you cannot write all the code of your company. You have to use some legacy code, to use some external libraries in which you cannot change the code. There is a very complex code you don't want to rewrite all, but you want just to use it. So if you have your variable staff in which it is a typed array list of employee, and you want to, for example, pass staff as a parameter to the method update. Is this dangerous? Is this legal? Is this permitted, etc.? So employee db dot update, if you have an object of type big capital employee db, it will be, for example, named small employee db. So dot update staff, you are passing your staff variable to this update function. So the method update expects any array list, and you are passing a special array list of employee. So staff object is simply passed to the update method, but maybe the update method, if you don't trust her, if you don't know exactly what it does, the compiler will let her add elements that are not necessarily employees to your staff, because it will consider it a raw array list. It can add, for example, strings. It can add, for example, big integers, etc. So this, you have to be caution. You have to take caution and to know if this is trusted update or no. If, on the other hand, you are assigning the array list to a typed one, for example, you are writing array list of employee result, your result is a typed array list, and you are getting the result of the returned value that find will return. So here find, as you can see, will return a raw array list. If this is the case, this will yield warning from the compiler, of course. And if you want to avoid this warning, you will have, for example, to cast. You will say, okay, cast the returned value to array list of employee. We will see now. And this is not good, because this is only misleading. So the cast is really, it doesn't really solve the problem. The problem will stay there. You can suppress the warning, you can add suppress warning, etc. But this is only to hide the warning, and there is nothing you can do about it unless you have to trust again, and you have to suppress the warning and continue your life. So we reached now the object wrappers and autoboxing, and sometimes you have to convert a primitive type. You need to convert a primitive type into an object type to pass it to a method that expects only object type, to put it inside a collection, inside an array list, etc. So for this reason, all the primitive types have class counterparts wrappers. We call them wrappers. For example, the class integer corresponds to the primitive type int. And so on. There are obvious names: integer, long, float, double, short, byte. These six inherit from the superclass number, so they have a common superclass called number. And on the other side, for the other primitive types, we have the classes character, the class void, and the class boolean. So the wrapper classes are immutable. You cannot change a wrapped value after wrapper is constructed. This is an information that is unknown by a good number of programmers, that if you wrap inside a wrapper class, the object will become immutable, and we will see an example just after our listing. And you must know also that wrapper classes are final, so you cannot subclass them. So, array list of integers, do you need this? Do you need a really array list of integers instead of an array of integers? You must pass a type parameter. This type parameter inside the diamond brackets, inside the diamond, cannot be a primitive type. So you cannot write here, you cannot, instead of array list of integer, you cannot write array list of int primitive type. So you need to construct an array list of integer type, and you declare var list equal new array list of integer. So of course, obviously, this is less efficient than an array of primitive type int, but sometimes you will be obliged to use this And as an advice, use it only for small collection. For small collections where the convenience for you is more important than the efficiency, because this is of course less efficient. So anyway, let us take this example in which we have our list and we want to add the value 3. Of course, here, as we said, this is a list of integer and not of primitive type int, but because of autoboxing and auto-unboxing, you can write simply list.add3 and the compiler will translate this to list.add and it will box the value 3 inside an object of type integer, and later you can write also int an equal list dot get of at the index I, and the compiler is gentle enough to unbox this. The compiler will translate this into int n equal list dot get I dot int value. Although you don't write int value, it's just like the toString. Anytime the compiler sees that you need the primitive type of the object, he will unbox it for you for free. Even with arithmetic expressions, when you write integer n equals 3 and then you write n plus plus, there is no plus plus operator for the integer type. So the compiler understands you need the int value and then you need to increment the int value, so he will do it for you. Okay, so he will unbox, increment, and then box again. So this is very convenient and you can use this without thinking. But you must remember these two properties, that they are immutable, the wrapper classes are immutable and they are final. So what are the difference? The difference is that an object does not have the equal operator to compare the state. For example, the equal operator applied to the wrapper object only tests whether the objects have identical memory location. Do you remember? This is the equal operator behavior. It tests whether those two object variables refer to the same object inside the memory. So, in principle, if you declare integer a equal 1000, integer b equal 1000, of course this is a primitive integer value. It will be automatically boxed into an object of type integer, and also here, but those two will be two different objects in the memory. Let us draw the memory here. I will open an Excel sheet. So inside this memory, I will have an object variable called A. This will be called A. Another object variable called B. And A, when I say A equal 1000, because of autoboxing, I will have an object of type integer inside the memory. Okay, this object is of type integer. Okay, you remember the UML notation? I will make this underline to describe that this is an object. Inside this object, let's suppose there is something called value. The value is 1000. And another object for B. The object reference A will be referencing the first, and the object reference B will be referencing the second, will be referencing the other object. So as you can see, if I test A here, will have the value, for example, at G of 4. Let's consider this is the memory. So this is G4. However, B will have the value here inside the memory G of 15. So it is G of 15. Let's suppose this, I know the memory is not an Excel sheet, but after all, the memory is also has addresses. So If I say A equal B, does A equal B? Of course, the answer is false. So this is what we are saying. So we are saying that comparing the values of the object references will lead to a most probably to false. Why we are saying may fail and we didn't say will fail, because we will explain now. But the best and guaranteed way is to call equals, because A and B are object references, so the best way to compare them is with equals. So let us see here in this listing inside the package wrappers, inside the test class wrappers test, we declared A equal 1000, B equal 1000, and as you can see, I compared them with A equal B and with equals. So before we see all the rest of the program that I will explain now, let us run and see that yes, A equal B will lead to false. However, A equals B will of course compare the states of the objects instead of comparing the object reference values themselves, and will lead to true. But we will continue our important slide, to say that the Autoboxing specification requires that Boolean, byte, char that are less than 127, short, and integer that are between 120 minus 128 and 127 are wrapped into fixed objects. This is called flyweight design pattern. So in this case, the equals will have to succeed. So in my Excel sheet, if I want to explain this, I will duplicate this sheet. So if this is C and D, if integer C equal 100, which is less than 127, so the recommendation of Java will say that C and D this time will be referring to the same object. This is Java specification. So here I will delete everything. This is Java specification. They are guaranteed in these intervals. So the equals will have to succeed. But if you write your code, just call equals. So here is the rest of the program. Integer A equal 1000, integer B equal 1000. If A2 is equal to A, and then I say A plus plus, you may think that since A is an object and it has incremented, so it will be, if I print A2, it will be also incremented. But now I am explaining that they are immutable. We didn't explain why they are immutable. So I will explain this on a, if I say A2 equal to A, I will have a third variable A2 called A2. It will be equal to A. This means it will have the same value as in A, copy paste. So it will be necessarily referring the same address as in A. So until now, A2 and A will be sharing the same memory. Okay, so let us continue in the example. If I then increment A, post increment A, what will happen? What will happen is that A will be auto unboxed, incremented, then auto boxed. What does this mean? This means that the integer will be copied into another simple integer value, so it will be, for example, temporary value here, okay, 1000, and this cell will be in the memory, and then it will be incremented. It will become 1001, and then it will be boxed again. So boxed again. So this is a copy of the space. It will be boxed again. We'll be referencing this in the memory. So if you print the value of A, it will be 1001, but A2 points always to the immutable object. You cannot mute the state of this object. You cannot mute the states of integers. So since now you have to refer to 1001, the object A refers to 1001. It means it points the address K14. So I will change the address here to K14. So again, if you go and print the value of A2, it will stay 1000, however, A became 1001. So, and here is the example for the 100, 100, the equals gives true, and the equals method gives also true. So let us continue our lesson and see that there are some subtleties that, for example, wrapper class references can be null. Since this is an object reference, sometimes it happens that this integer n stays null or is passed as a parameter and without being referenced, or etc, etc. So watch out for such calls. System.out.println 2 times n, where n is a null value. The compiler will try to auto unbox this, and there is nothing referenced by n, so it will of course throw a null pointer exception. Mix integer and double also is another subtlety, inside which, for example, here you have integer n equal 1, double x equal 2.0, which are both auto-boxed into integer and double types. And if you then say true, if true, then print n, and else print x. This is mixing inside one instruction. Regardless of the answer, the x will be the n will be unboxed and then boxed again into a double, because it exists in the same instruction with a double. So instead of printing 1, it will print 1.0. All of these subtleties and more, you can see them later if you do a Master 2 in Cybersecurity. We will take together a course called Secure Coding, in which we will draw your attention to such things which are very, very dangerous in coding. So another thing is that inside the class integer, the librarian chose to also put some static methods. Regard here, look with me, integer without instantiating. So this is a static method called parseInt. If you have a string and you want to parse its int value, you can use the parseInt from the integer class. So let us check together, for example, the integer class and the number format class, and then we will be back to the wrappers package to see the wrappers test class. So let us go and see the documentation for the integer class. Okay, we want the integer class, which is a subtype of the class number, as you can see with me. In this integer class, you can see there is method, there is for example a match method, and there is the parseInt method, which is of course a static method. So it is a function which parses the string argument assigned in decimal. And of course we will find the equals method and the hash code method, because they are used to compare objects. And if you click on equals, they will tell you that they compare the states. So the listing wrappers, we already saw it, and so this is all about this section, and next we will see the methods with variable number of parameters. So this section is about methods with variable number of parameters, and this is a very easy section. Before Java 5, every Java method had a fixed number of parameters, and since Java 5, it was possible to provide methods that can be called with a variable number of parameters, you guessed it, and it is called Varargs method. For example, the method printf of the outstream takes sometimes 2 parameters, sometimes 3 parameters, and so on. So how is it done? It is defined as follows. So if you enter the class printstream, you will find the definition of the method printf, which takes only 2 parameters in fact. String fmt, which is the format which is inside the printf always present, and the other one is the object ellipsis args. What is this syntax means? It means an array of objects. So it is the same thing as making a square brackets. And then it will call another method which is also with a variable number of parameters, which takes an object array. So what are the ellipses? The ellipses are the 3 points. They are a part of Java, and it denotes that the method can receive an arbitrary number of objects. So this arbitrary number of objects is actually an array of objects, an array of type object that can hold this all the other parameter, all the arbitrary number of objects. So if the caller supplies primitives as arbitrary number of objects, as you can guess, they will be automatically autoboxed into an object type. For the implementer of printf, object 3 point is exactly the same as object square brackets. So you can easily say, instead of giving the parameters one by one, you can put them inside a new array of objects and provide their values here inside the object. Because if you don't do this, the compiler will do it for you. So a function that computes, for example, the maximum variable number of values is the following. You declare max as public static double, and how much values it takes. It takes an arbitrary number of values. So you declare double 3 points, this is the ellipsis, values. It's the same thing as if you have declared an array of double. Okay, so and then you initialize it to the least value of double type, and then you do the for loop, and every time you find a larger, you make the largest equal v, and you return the largest. So this is a very easy method, but in which we have shown you how to use the variable number of parameters. You can call this method with 3 parameters, 2 parameters, 1 parameter, etc. And for example, you can call it by passing the values 3.1, 40.4, and -5. And look how the compiler will think. The compiler will have to cast them to a common type, because the compiler will put them inside an array. So what is the most obvious common type? It is an array of double. Okay, so the compiler will pass a new an array of double to the function max, and it is legal to pass instead of this an array as a last parameter. So and then also in the main function of the Java have a variable number of arguments. It has string 3 points args. Next, we will see the enumeration classes, followed by the reflection, and we will finish by the design hints for inheritance. Enumeration classes section, it will be short but important. We declare enumeration, as you all know, like the following. For example, I have the enumeration size of clauses. I declare public enum size or just enum size, whatever. And then between the curly braces and before the semicolon, I put the list, the enumeration list. So this type is defined, the size type that is defined now is actually a class. It is actually a class and not any class. This is a very complicated class, but you have to know that this class will have only 4 instances, and those instances are constant. So this is a class which will have only exactly 4 instances that are constant and no other new object can be made. So you can easily use the equal operator to compare whatever values of this enumeration because they refer to the same objects, to either one of the 4 objects. So you have to know also that you could have added constructor, you could have added methods or fields to your enumeration easily, just like this. Enum size, small, between parentheses you give the letter, the string S, the string M, and the string, for example, XL and L. And what does this mean? This means you are giving a constructor which is not default, which take a string, and this string you are going to put it inside your instance field abbreviation. So you declare it private string abbreviation, and then you can also declare a getter for this abbreviation. But notice here that always the constructor of an enumeration is always private. If you miss to put private, it will be private. If you put public or protected, the compiler will complain. The compiler always complains. Its job is to complain, but he will complain for this particular thing. So what else do you want to know about enumeration? I will tell you that all enumerated types are subclasses of the class enum. Okay, so there is a certain class enum, and all the types, for example, our type size here is a subclass of enum. It extends enum. So it inherits its methods, and particularly the method toString, very useful in order to return the names of the enumerated constant. For example, you can use it like this: size.small.toString. It will return, not print, it will return the string small. And you can use also the value of method. The value of method will be used, for example, like this. You declare an object reference S of type size, and then you call the value of method of the class enum, which is a static method, and to which you will give 2 parameters. The first one, the second one is the value of the string you want to have, and the first one is which class do you want to have this value. Because this is a static method, you must precise at each time which class. In our case, it is the size.class class. So, and then what does it will return? It will return the value of the string. The value of the string is the instance size.small. So all the 4 instances are also static fields inside the class size. So also we have the values method, which is also static, and it will return this time not only one value, it will return an array of all the values of the enumeration. Just use it like this: size brackets square brackets values, receive them in an array of sizes, and call the method values of the type size, which is inherited from the type enum, of course. What else do you have? You have the method ordinal, which will return the position of the constant in the enumeration starting from 0. So, for example, ordinal of small is 0, ordinal of medium is 1. Enum class, in fact, it has a type parameter. So this is a generic class, and it has a type parameter that is ignored for simplicity. It is very, very complicated. You will see just in seconds. since actually size actually extends enum of size, because enum is the parent class, is the superclass of size, and in the same time size is the type parameter of enum. So you see how much it's this complicated. Why do we need a type parameter? We need a type parameter inside enum class in order to do compare to. You will understand this, what I'm talking about now, when you study with me the chapter generics, the chapter collections, and the chapter interfaces, next chapter interface, because compare to is explained in detail in the chapter interfaces. What do we have to see now? We will check the Java documentation, and inside the Java documentation, we will see the enum class, of course, and after that we will go and check the listings of the package enums. So let's go to see the documentation. This is the enum class. Notice with me how complicated is this syntax, even when you will study the generics chapter, when we will study it together, this will still stay complicated. Class enum type parameter by E, where E extends enum E. This is a form of recursivity. When does this end? Okay, and then let's focus on the important thing. We talked about the methods toString, the methods ordinal, the method value of, and they are all here. And as you can notice, value of is static, and that's it. So let's go back now and see the listing. As you can see here, we have the same thing as we saw together. We have declared an enum size in which we put a private constructor, we put get abbreviation and abbreviation private field of type string, and then we have a small program which reads from the scanner the size. Let's try to put, for example, a certain size, small. It will read it to uppercase, and then it will print the size, it will print it, and then it will print its abbreviation, which is S here. And then if I have put extra large, it will print something special in order to show that we can compare with equal. So let us run again. And let me this time enter extra underscore large, and the size is equal underscore large. How did it print the size? Size equals size enum value of size.class and the input red, which is the string extra large transformed into capital letter, and then it compares the size with the constant instance, static instance that is present inside size, and since they refer to the same object reference, that's what I am explaining, they refer to the same object reference, there is no more than one instance extra large, so whenever you use equal, it will be the same. So it will print, good job, you paid attention to the underscore. This was our section about enums, and next we will do reflection. Reflection now. We reached the section reflection, and let's begin by defining the reflection. The reflection library gives you a very rich and elaborate toolset to write programs that manipulate Java code dynamically. Using reflection, Java can support user interface builders, object relational mappers, and many other development tools that dynamically inquire about the capability of class. When you say dynamically, it means at runtime. So a program that can analyze the capabilities of classes is called, by reference, reflective. The reflection mechanism is extremely powerful. What can you do with reflection? You can use reflection to analyze capabilities of class at runtime, to inspect objects at runtime. You can, for example, like you will see today, write a toString that works for all the classes to implement generic array manipulation code. Also, this is a code available. And to take advantage of method objects that work just like function pointers in the language like C++. However, this tool is interesting for tool builders mainly and not like for application programmers. So you must know about the reflection tool, but you don't need to overuse it. Okay, we will see at the end of this section the recommendation. Let's begin by introducing the class. The class name is also class. So when new classes are added at design or runtime, you can dynamically inquire about their capabilities. You can at runtime ask something about the class or about the object, etc. So runtime type information is used by the virtual machine to select the correct methods to execute. We saw this in the previous video lecture, in which we saw how the virtual machine resolve which method to invoke at runtime, and this was called the dynamic binding. It can access this information. The virtual machine can access this information by working with the class. What is a class? First of all, you must know that the getClass method that you saw in the object class returns an instance of the class type. For example, if you declare the employee E and then later you initialize it to an object of type employee or a subtype of employee, and then you don't know which type is the actual type of the declared variable E. Is it manager? Did I say later new manager or new employee or new secretary? So I want to know which class the object reference E refers to. I can invoke the getClass method. I can ask e.getClass and it will return me an instance of type class. So a class object describes the properties of a particular class. In particular, you can invoke getName method over this object and it will return for you the name of the class. For example, we used this when we implemented the toString method in order to print the name of the class whenever we wanted. We said system.out.println e.class.getName instead of printing always employee, because maybe the actual type of E is manager, so we wanted to print manager instead of printing employee. And for example, this will be the output. For the employee, it will print employee, and for the manager, it will print manager. If a class is inside a package and we invoked getClass.getName, so the package name is part of the string that will be returned by the getName method. For example, var generator equal new random, and then you get the class and then you print the name. The name will be java.util.random. The class, the virtual machine manages a unique class object for each type, just like we saw with Enum and with, for example, size. In the section Enumeration Classes, we saw that the example given, the size type, has 4 instances only. Also, the class manages a unique class object for each type. If I have two objects of type employees and I invoke over them the getClass method, the getClass method will return a reference to the same object representing the class employee. So if you have if E, you can compare now using the equal operator, because E.getClass will be always equal if the class, the actual type is employee, will be equal to the employee.class, because there is no other instance that will represent the employee class. So as you can get the class of the object, you can maybe create an instance of on the fly, but this version of creating an instance of the fly is deprecated. What is deprecated? As we all know, a program element is annotated as deprecated is one that programmers are discouraged from using. Why discouraged from using? This method new instance for the get class was already here. You can see this. It was here inside the class. This is the class. You have the get instance method. It was already here, but new instance, sorry, and it will tell you this is deprecated. Every time you have to check the Java doc whether a certain method is deprecated in order to not use it in the future. It will stop being supported in the future, and more importantly, it is likely to lead error, and it has been superseded by a newer, usually preferable alternative. So what is the alternative? Is the method for name get constructor plus new instance. How? Like the following: var name, you get, for example, the string representing the class, and then you invoke the for name method. So you get the class representing this string, so you return an object of type CL representing the class for the string. So you have now the class random, and then you want to create an object of this type, so you say object obj equal class dot get constructor. You get the constructor of the class random dot new instance, and this is just like if you were writing object obj equal java dot new random constructor. But this reflection code will be used whenever you don't know which string. Maybe the string is input by the user. Maybe the string is variable. So this way you can invoke the default constructor with no arguments of the string of the class representing the string. So we introduced the class and the get class method, which is inside the object class. But as a primer on catching exceptions, as a recall, you know that when errors occur at runtime, a program can throw an exception, like class cast exception, null pointer exception, etc. So throwing an exception is more flexible than terminating a program because you can provide a handler that catches the exception and deals with it. If there is no handler, the program then terminates and prints a message. There are two kinds of exceptions. You must know that there are two kinds of exceptions: the unchecked exceptions and the checked exceptions. For the checked exceptions, the compiler will help you, will tell you you didn't provide this handler for this exception. The compiler checks that you provide a handler. That's why it's called checked exception. As for the unchecked exceptions, those are exceptions of the type that the compiler cannot guess them. It's like accessing bound errors, accessing an array outside the array, or dereferencing a null pointer, or etc. etc. So those are unchecked exceptions. The class dot for name method throws a checked exception. So that's why when you use this method, whenever you use the for name method of the class, you must the easiest way to deal with this is to declare that the method using it will throw this exception by her turn. So if the method do something with class, will use the for name method, it must state in its signature that I am also throwing by my turn. Whenever the for name throws this exception, I will throw it also by my turn. So as an example, let's analyze the capability of a class using reflection. To take a brief overview of the most important parts of the reflection mechanism, let's examine a structure of a class. First of all, we must know that like the class, there are also three other classes in particular, which are the class field, the class method, and the class constructor, and of course to represent instances of the fields, methods, and constructors found at the runtime. So you can find all these classes in the Java Lang reflect package, and all three they have the get name method, which returns the name of the item. So get field, the class field has the get name, and it will return the name of the field of a certain class. In particular, also the field class has the method getType, which will return an object of type class, because a field has a type also. And you remember that the type class also has representations for the primitive types also. So methods and constructor classes also have other methods to report types of the parameter. Let's check this in the Java doc. Let's check the class, the class field, the class method, the class constructor, and the class modifier. Go to the Java doc and, for example, type the class name field. And attention here, there are too many classes name field. That make sure to select the field that is inside the Java Lang reflect. So if I select this class, I will see among others, the getName method, which will return the name of the field represented by this field. And as you can see also, they will advise you to see also the class member, class, the method getFields, inside the class, and the method getField, which without s, and getDeclared field, and getDeclared fields. So and you can see all the information here. Let's check the class constructor. Also, it has methods to get, for example, generic exception types, to get generic parameter types, to get name, to get parameter annotations, parameter count, and to get the type of parameters, which will return an array of type variable, and so on. So this is the reflection world. Welcome to the reflection world. You just see everything. So as an example, the textbook provides a package reflection in which he defines a reflection test class that shows you how to print out all the information about a class. It will prompt you for the name of the class of your choice and writes out the signature of all the methods, the constructor, as well as the names of all the instance fields of a class. What is remarkable about this program is that it can analyze any class that the Java interpreter can load, not just the classes that were available when the program was compiled. So you can create a class. This program will analyze it. Used in this chapter, this example that we will see now will be used in the next chapter also to peek inside the inner classes, because in the interfaces chapter we will see interfaces and we will study also inner classes, and we will use again this program. So let's check into this listing called package reflection. So this is the package reflection. This is the class reflection test, and as you can see, inside the reflection test there is the main function which throws reflective operation exception. You can deduce this as a checked exception, so you have to throw it by your turn or to catch it. And then this function sees either the args of the main are not null, so the length is greater than 0, so it takes the class name that you want to inspect from the args, or it prompts the user to enter the class name of his choice. And then the name is set. Once the name is set, you call class for name, and then you you take the superclass of this class, and then you take the modifiers of this class, and then it calls three different methods, which are print constructors, print fields, and print methods, in order to print all the things of this class. Let's try it. Let's give, for example, java.util, as it says, dot, for example, calendar, and so as you can see, it prints for you all the stuff of this class, even the public, the private and protected fields. Look, it can see the private fields, but this is not going to last, because this is not good. By reflection, you are sneaking inside the class, you are seeing even the private methods, the private fields, the protected fields, etc., even from outside the package. So this is really not good. But this is how powerful it is. It is so powerful that it becomes very dangerous. Okay, so this was our analyzing the capability of the class. Another program also provided by the textbook is now to analyze a specific object. You can analyze objects at runtime also. How? You can go one step further and actually look at the content of the fields, not only the field names, but also the field values. So reflection lets you look at fields of objects that were not known at compile time. The key method is to achieve this is to get the method in the field class. So inside the class field, there is a method to get this field. It is called getDeclaredField. And if f is an object of type field, and object is the object of class of which f is a field, so you can say f.get obj, which will return an object whose value is the current value of the field of obj. As simply as that. Object is the object and f is the field, and then you get the value of this field inside this object. This is a hassle-free and undoubtedly useful method for supplying a universal toString method. You can, using this reflection, you can provide a toString method. However, before you get too excited about never having to implement toString again, remember that the days of uncontrolled access to internals are numbered. They must be numbered, because this is insecurity. This is insecurity for all the encapsulation process. So that was all what I wanted to say about reflection. Reflection is a big section in the chapter 5 in the textbook. I draw your attention to this section if you are interested of reading more of it. We didn't do all the subsections. So we will end this huge chapter about inheritance. We will end it by design hints for inheritance. This is a very nice section. It will recapitulate all what we have said during the chapter. So first of all, place common operations and fields in the superclass. The name field, we placed it into the person class because both person types have name, like employee has name and also students have name. If you place it upper level, you will benefit from the polymorphism. So another advice and another hint is to do not use protected fields. Do not use protected fields, as simple as that. Even if you are tempted to, we explained in the previous video that protected fields are very dangerous to use, and they are not really the reason is not really convincing. You will always find a better way to accomplish your goal. Protected mechanism does not give much protection, even though this is contradictory a little bit, but yes, protected mechanism does not give much protection because a set of subclasses is unbounded especially when the set of subclasses is unbounded, especially when the class is not final. Anyone can form a subclass of your classes and then write code that directly access protected instance fields, thereby breaking encapsulation. And of course, you don't want to break encapsulation. All the classes in the same package have access to protected fields, whether or not they are subclasses. However, protected methods can be useful to indicate methods that are not ready for general use and should be redefined in subclass, especially the famous class method, method clone, which we will study in the next lesson. Another hint is the hint number 3, which is use inheritance to model the is-a relationship. Sometimes people overuse inheritance. For example, suppose we need a contractor class. Okay, contractor. Contractors have names and have hire dates, but they do not have salaries. Instead, they are paid by the hour, and they do not stay around long enough to get a raise. So not all the employee logic applies to them. There is a temptation to form a subclass constructor from the employee and add an hourly wage field like this. Class contractor extends employee and then adding the field hourly wage, but this is not a good idea. The contractor-employee relationship fails the as-a test. When you say is a contractor an employee and a contractor is an employee, this is false. A contractor is not an employee. So you must remember this rule before being tempted to extend a class. So a contractor is not a special case of an employee. Therefore, do not choose inheritance unless all inherited method makes sense. Not only the as-a relationship is important to be applied, but also above the as-a relationship, you have all the inherited methods that must make sense in order to use a supertype. Suppose we want to write a holiday class, and surely every holiday is a day, so the as-a relationship here is applied. But this is not sufficient. This is a must, but this is not sufficient. And days can be expressed as instances of the Gregorian calendar class, so we can inherit. We can say class holiday extend Gregorian calendar. But inside the Gregorian calendar class, there are lots of methods. Among those methods, there is the add method, which can to which you can give 2 parameters, and you can, for example, add 12 days to a given day. If you declare a holiday Christmas, which is December 24th, and then you add 12 days, but because you inherited the add of the Gregorian calendar, then it is not a holiday anymore. So you applied wrongly the inheritance mechanism. You used the mechanism, but you made a big mistake. A holiday added to it 12 days is not a holiday. So here there will be lots of debate. You will say, I have to override the method add, and then they will tell you, but when you override the method add, you are changing its behavior to add 12 holiday days, and this is not good, and we will see in the next rules why. But you have to know that inheritance here, in this case, is not an appropriate solution. Note that this problem does not arise if you extend the local date instead of extending the Gregorian calendar type. And because that class, the local date class, is immutable, and therefore there is no method that could turn a holiday into a non-holiday. It is immutable, so another object will be created and a holiday will stay and will remain a holiday. Rule number 5, do not change the expected behavior when you override a method. This is what I was mentioning in rule number 4. If you wanted to correct you, do not change the expected behavior when you override a method. Not just because you can override, you can change the behavior. You must respect Even if the compiler cannot guess that you are changing the policy of the class, you have to not to change the policy of the class. The substitution principle applies not just to syntax, but more important to behavior. For example, you can fix the issue of the add method in the holiday class by, for example, redefining add, perhaps to do nothing, or to throw an exception, or to move to the next holiday. However, such a fix violates the substitution principle, the sequence of statements to consider. Consider this. So if we consider the sequence in which we have X, a holiday day, a holiday object reference, and then in which also you have redefined the add method in order to provide the next to add only holiday days to the date, and then you wanted innocently to get the day of the X and then to add to the X1 one value, which is now redefined to add to go to the next holiday, and then you get D2, which is the day of the month after the adding one, and then you wanted to print the difference between D2 and D1. As you can expect, the normal behavior before redefining add, it was if D2 is, for example, a next day, it will be the value 1. But since you redefined add, and now you cannot expect the difference between the two because of this behavior. So the rule of thumb here is that you should have the expected behavior. You should have the expected behavior not to change, no matter whether X is of type Gregorian calendar or holiday, because the users of the Gregorian calendar class are used to get the difference of in days between the two values, and now the difference will be changed because another method in the class was overridden. So here reasonable and unreasonable people can begin to argue at length about what is the expected behavior, but nevertheless, don't do this. Don't do this. Don't use inheritance in order to change the logic of the class. Rule number 6, polymorphism. Use polymorphism, not type information. So whenever you find your code in the form of if X is of type 1, action 1 of X, else if X is of type 2, action 2 of X. What is this? If, for example, get class or instance of or whatever. No, don't do this. Instead of it, think polymorphism. Do action 1 and action 2 represent a common concept? If yes, if so, make the concept a method of a common superclass of X or interface of both types. Then you can apply X.action, and using dynamic binding and the dynamic dispatch mechanism inherent in the polymorphism, launch the correct action, as we can see in the, for example, getSalary method in the beginning of this chapter. The code using polymorphic methods or interface implementation is much easier to maintain and extend than code that uses multiple test types, and the explanation is obvious. Suppose you added another type. If you use polymorphism, the dynamic binding will resolve the issue. But if you don't use it, if you are using this classical imperative way, not object-oriented way, you will have to open your code and write another else statement here. And this is not reusability, this is not expandability. And the last rule of this lesson, do not overuse reflection. The reflection mechanism lets you write programs with amazing generality, but by detecting the fields and methods at runtime. This capability can be extremely useful for systems programming, but it is usually not appropriate in application. Reflection is fragile. The compiler cannot help you to find programming errors. Any errors are found at runtime and result in exceptions and not in compilation errors. So, this was about our chapter, and what will we see next? Next, Until now, you have seen how Java supports the fundamentals of object-oriented programming classes, inheritance, and polymorphism. In the next chapter, we will tackle two advanced topics that are very important for using Java effectively, which are interfaces and lambda expressions. So see you next time.